Types of weathering. Weathering is the name given to the process by which rocks are gradually worn away by the action of the weather. Two important classifications of weathering processes exist: physical and chemical weathering, each sometimes involving a biological component. Minerals that were once bound in the rock structure, yet were released during the process, could combine with organic material to create soil. In addition, many of the Earth's land forms and landscapes are the result of weathering processes combined with erosion. Physical weathering is the weakening and subsequent disintegration of rock by physical forces, including temperature fluctuation, abrasion, frost action, and salt crystal growth. The rock expands when the temperature of rock increases and contracts when it decreases. Such alternated process can crack or break rock. Abrasion of rock is caused by the friction of water, wind, or ice upon the rock, the continuous exposure to which slowly breaks down the exposed surface of the rock. Frost action is the repeated cycle of ice formation and ice melt in the pore spaces and fractures of rocks, causing disintegration of the rock. Salt crystal growth occurs when groundwater moves into empty pores or spaces of rock by capillary action. As the water evaporates, salt crystals grow and accumulate, putting pressure on the rock and causing it to break apart. Chemical weathering is the disintegration of rock by chemical reactions between water, oxygen, and carbon dioxide with the chemical composition within the rock. Water is a key player in this process. It can be absorbed by the minerals in the rock through a process called hydration, creating crystals that cause the rock to expand and finally leading the rock to crumble apart. Moreover, hydrogen from the water also readily reacts with the minerals in the granular rocks through a process called hydrolysis, which undermines both the rock's chemical composition and crystalline structure, making them more susceptible to breaking down. Carbon dioxide from the air is not reactive, but it often dissolves in rainwater to create a weak acid, carbonic acid, which over time will dissolve or break down many kinds of rock, especially rocks which contain calcium carbonate, such as limestone and chalk. More often than not, the acid would completely dissolve the original rock, leaving nothing solid behind. The reaction of rock mineral with carbonic acid in this way is known as carbonation. This type of chemical weathering is responsible for all of the world's spectacular limestone caves, which form when dissolution occurs along a series of fractures in the limestone to create a larger opening. The dissolved limestone is transported through the cave and may be precipitated to form new features such as stalactites that grow downward from the cave ceiling and stalagmites which grow up from the floor. Apart from water and carbon dioxide, rocks exposed to the air are also subject to oxygen, the most reactive gas in the atmosphere in abundance. Oxidation then is another kind of chemical weathering that occurs when oxygen reacts with rock minerals and creates compounds called oxides. The most common metal involved is iron, which reacts with oxygen to form iron oxide minerals such as hematite, a kind of red-colored rust. If water is present, as is often the case, hydration occurs in conjunction with oxidation to form hydrated oxides such as limonite. Since these oxides tend to be structurally weak and easily crumbled, rocks become less resistant to weathering when minerals in them oxidize. Biological weathering occurs when living organisms cause the rock to break down. It is actually a process in which living organisms can cause both mechanical and chemical weathering to occur. For example, tree roots can grow into fractures in a rock and pry the rock apart, causing mechanical fracturing, or they can produce a weak acid that dissolves the rock in order to either gain nutrients or make little holes for the rootlets to grow into. Microbial activity can also break down rock minerals by altering the rock's chemical composition, thus making it more susceptible to weathering. One example of microbial activity is lynching, which consists of fungi and algae that live together in a symbiotic relationship. Fungi release chemicals that break down rock minerals. The minerals thus released from the rock are then consumed by the algae. As this process continues, holes and gaps continue to develop in the rock, exposing the rock further to physical and chemical weathering.